Guys, my name is Arash. Welcome to my YouTube channel Datatodeploy. In this video we want to talk about how we can clean our data with pandas library in Python. Here we will run the codes on googlecolab. As you can see here, we use Kaggle dataset. We import the data, we download the data, and we begin to work on this dataset and clean our dataset. Here in my GitHub account, I also put all these codes in the repository. Here, pandas data cleaning, you can simply clone it to your machine and run each capsule separately and see the result. I put the link in the description, and also if you need more details, I wrote an article about this. I also put this link in the description where it's my blog. You can read all the details about how you can clean your dataset with pandas in Python with all the codes and outputs and description you need. And also don't forget to subscribe to my channel. I highly need your support. I want to get to 1000 subscribers. If you subscribe to my channel, I highly appreciate it. Let's jump into our code. And one thing I want to show you to understand the content better is that, for example, here this is Nemudo, the web application. I'm working on it. Here we can simply upload our dataset and visualize our dataset. Here you can see that our total records, number of columns, how many of them are numeric, how many of them are categories, how many missing values we have, how many outliers we have. And if we click on generate dashboard and view dashboard, we can visualize our data set. I'm working on this application, web application. I wanted to show to you here. For example, you can see that this is the houses on all type of charts. We can see compare features to them on Nemudo. I put the link in the description. Go check it out and upload your dataset and see how everything is working. So in this guide, we want to use New York City Airbnb dataset, which we get it from Kaggle website, and download this dataset straight in Kaggle website, or also Kaggle put the link. We can download it with the link instead of downloading the CSV file and then upload it in googlecolab. With this line of code, we can download the file from the Kaggle servers. Here you can see on Kaggle, this is the page where the dataset exists. You can simply click download and download it as a zip, or you can copy this. Let me check this one. You can copy this and paste it in your Google Colab as what I did. Here, for example, we import Kaggle Hub, and from Kaggle Hub we import Kaggle dataset adapter. We run this capsule, and in this data cleaning we want to manage missing values, duplicate values, duplicate entries, incorrect data types, inconsistent formatting, and finding outliers, which outliers skew our result. And fixing this may let us ensure that we will get accurate and consistent result in our machine learning models or data visualization. So after we run importing libraries, we need to first define the name of the file path we want to download. The file name is ab_nyc_2019.csv, and here you can see that we call Kaggle hub dot load dataset, and first parameter Kaggle dataset adapter dot pandas, and this is the path where we want to download it from Kaggle. Here you can see that this is what Kaggle provides for us, and we simply copy paste it. And then after we get the data, we want to print the first 5 rows. We hit enter, and now we can see the first 5 rows of our New York City Airbnb dataset. Here you can see that we have lots of columns and just 5 rows. For example, you can see the name of the property, host ID, the property owner, for example, the neighborhood, or the latitude, longitude, the type of the room, for example, it's private room, or it's share room, or it's the entire home, the price of it, the minimum nights someone try to stay there, how many reviews that property got on Airbnb, and few more features. And here we can check the shape of our data set, and it's very good before we jump into cleaning our data. It's very good to learn more about our data set. For example, the shape of our data set, our featured data types. This help us for our next commands we want to run. For example, you can see that we have 16 features, 16 columns. For example, here the ID is also one column, which maybe we can remove it, and we have 48,895 rows. Okay, we just saw 5 line of them, but we have near 49,000 rows of data. And with df.info we can check that the data type of each column. For example, our ID column have integer 64 data type, our name column has object data type, this one, and our host ID has int 64. Here we can see the data types. And another important thing df.info tell us is that we can see that how many null value we have in our data set. For example, you can see that we have 48,895 entries, and some columns have some missing values. For example, name, you can see that we have less than 20 missing values, or host name again less than 20 or maybe 21 missing values. But here for last review and review per month, you can see that we have near 10,000 missing values. These two features has the most missing values in our data set. So with df.info we understand it, so we know what we should do for our data pre-processing for the next part. Another important metrics we can check for our dataset is df.describe. Okay, with df.describe we can see our numerical columns, mean, standard deviation, minimum 25%, 50%, 75%, and max, and the count of them with df.describe. Also, I say it again, it's df.describe will work only for numerical columns, not for categorical columns. And here I use .t, which means transpose. I can delete it. Here you can see that we have 16 columns, 16 features, and for the numeric ones, most of them are numeric, so you can see that some of them go beyond the screen and we need to scroll to see the value. Okay, with T transpose, we can switch the column and rows, so all of them appear on one screen, so we don't have to scroll the screen to see other columns data. Here you can see that, for example, these are our numeric columns, for example ID, host ID. For example, here we can see price. We don't have any missing values for price, and for example we can see that the mean is 1.5, and here minimum value is 0, 25% is 6.9, 50% is 1.06, but we can see that this is with e plus 0.1 and this is e plus 0.2, and the maximum is 1 plus e plus 0.4. Here, for example, we can understand that in price we have outliers. Most of the values are here around 1 to 2 e plus 0.2, but the maximum is 1 e plus 0.4. okay, this is outlier. Most of the value are below 75%, but we have some value which have the long distance from the most of the data sets, so we call these outliers. And later we will understand outliers, and I will show you how you can visualize the outliers so you can understand them better. And other values, we can see that to see which one have outliers. For example, again, minimum noise, you can see that the minimum is 1, and 50%, half of the data set are 3, and but the maximum here you can see that is 1.25 e plus 0.3. okay, this is a very huge gap between the most of the value and maximum. So here e means exponential value, and for example here which means that 1.25 cross 10 in power of 3, which will be equal to 1250. And compare it to here, e here plus 00 means 10 power of 0, which equals to 1. So 75% of our minimum noise are around 5, but then the maximum value is 1250. So this gap is showing us we have outlier. Next we saw the df head before, so we move the next part. For example, handling missing data. So first command is we can run df.isNull.sum. when we run .sum, it will sum all the true and false values. So simply with df.isNull we get a true and false value. Okay, so and then with .sum we sum all this value and get the final result. For example, we have 16 missing values for name, 21 missing values for host name, and 10,052 missing values for last review and reviews per month, which we saw in df.info. And with isNull.sum we sum the value and we get a clear output. And here also we can, for example, get the percentage of missing values. With this command we get the number of missing values, and with the next command we can check the percentage of the missing values by simply dividing the sum of the isNull value by the length of df cross 100, and we get just rounded to just 2 float value. Okay, if we run it we can see that, for example, 10,000 missing value equals to 20% of missing value. So out of near 49,000 line of rows which our dataset has, 20% are missing in these two features. But for the name and hostname, they are very small, and around 0.03% and 0.04% for these two features. And the next thing we should decide is to removing the missing values or fill it. We can simply drop the missing values, or we can fill it based on mean, based on mode, or we can even generate some artificial value for the missing values. Okay, there is no one single approach. It depends on the what value the missing values give to our dataset. If dropping the missing values affects our analysis, maybe we should keep them and fill them with some values. Or if we can see that they didn't give us any significant value, we can simply drop them. Okay, for dropping we can simply write df.dropNA and with subset equal to in the bracket the feature name. For example, these two features they are very small. If we drop them, nothing important change in our dataset, so we can simply drop these two. And if we check the shape, we can see that nearly 40 lines dropped. Okay, it's very small. Another thing we can fill. Okay, so for the features we have 20% of missing values. If we drop them, we will lose a huge data, because other columns have some data. Just these two columns have missing values, and if we drop these rows, we lose very important data, important things from our dataset for analysis, so we can fill them. For example, here for reviews per month, we simply tell that this feature in data frame df.fillNA, filling the non-value to 0. So if we have non-value, we replace the non-values with 0. So which means that we have 0 reviews per month for that specific row. And also for last review, again we fill that non-values with 0. So for example, that row has 0 review on that row. We run this, and with df.info, here we can see that these two columns, now we have same values as all other features, so we fill them with 0 value. Next thing is for example, our column last review has datetime data type. For features with datetime, it's better to not add for example random value, because this is time frame and it's important to have that sequence. If we don't have them, we can simply leave the value with NAT, which is the pandas null for time stamps. Okay, here we simply tell that for this feature in our data frame, we turn the data frame. If we have any null value, we put NAT for that missing values. We run these two commands. And also, for example, for errors we have 4 options, which I talked about it on my blog. For example, the default is race, which means that it's when it reached to that row with a missing value, it stops the execution and throw an exception the moment it hits a single unparsable value. With the one we use, coerce, it converts whatever it can and turn anything invalid into NAT, not a time. And the third option, we have three options, is ignore. Simply used to leave invalid values untouched instead of raising an exception or change it to NAT. And after that we can again see our df.info. Here we can see that we changed the zero value with NAT, so we get again around 10,000 missing values because we have NAT. But for datetime features, it's a good practice to turn the missing values to NAT. Then we can remove the duplicates value. Okay, so duplicates happen in our data frame dataset. For example, maybe some rows exported multiple times, or when we try to gather data, we put same line twice or more in our dataset, so we can find them and remove them. Here I try to add some duplicate rows sample. We had some missing values, so for duplicate rows, for example, here with df.sample and n equal to 500, which means that 500 of rows with duplicate rows we generated, and we concat it with our main data frame, and again name it df. And here with again df.sample, when we concat the duplicate rows with our main data frame, they added at the end of the main data frame. Okay, so at the last row of main data frame we can see 500 duplicate rows, but with df.sample again and fraction equal to 1 and random state 42, so we simply divide the duplicate rows into our data frame, and then we print the main data frame shape and how many duplicated we have with ID column. We can see that after adding 500 duplicate rows, our number of rows increased to 49,358, and duplicate IDs are 500 rows. Then here we can detect our duplicates. We simply we call the data frame, and inside brackets df.duplicated, we get the duplicated values, and we name it, give it a feature value duplicates, and then len of the duplicate, we can see that we have 500 fully duplicated rows. And here you can see that in our dataset we have the ID column. Here, for example, we can see that in our data frame the ID column dot duplicated dot sum, we can see that how many duplicated value we have in our data set with the same ID column. You can see that 500 of our rows have same ID which are duplicated, and we can simply by running df.drop duplicates drop these duplicate values, and if we again check the data frame shape, we can see that we go back to 48,858 number of rows. Another thing we can do that is that, for example, imagine in our data set only some of our features or column have same value. Okay, here I try to, for example, instead of having duplicate values which have same column feature value, imagine just 3 of our columns have same value. For example, host ID, latitude and longitude. We generate a sample of 500 rows, and then we put this host ID, latitude and longitude from our main data set into partial duplicates data set we generated here. So then we can concat this duplicated partial duplicated data set with our main data frame, and then again we divide these duplicated values across all the data frame, so all they don't stay at the end of the data set, they divide in between the data set, and then we check how many duplicated we have in our main data set and how many. For example, let me run this. You can see that the full row duplicates are 0, but when we check the host IDs, we can see that we have 501 rows sharing host ID which are duplicates. Okay, so this means next part is to fixing incorrect data types. For example, we can run df.dtypes or df.info. With dtypes we just get the data types. We can see the number of existed values and missing values. And here, for example, in the previous part we talked about how we can change the date time for this feature, and also we can do the same for price feature with pd.toNumeric. We simply try to change all the values in this column in this feature to numeric. If we have, for example, a $sign or a column, semicolon, anything in our values with errors, queries, we simply change that value into NaN. Okay, for the numbers it turns to NaN, but for date time it turns to NAT. We simply run this, and here we try to fixing inconsistent formatting. For example, for our neighborhood column, we give this column to turn all the values into a string, and dot stripe will simply drop the white space between the words in that column. Okay, and for example, df neighborhood dot string dot title. With dot title here also I explain it, we can take a look at. With dot string dot title, we simply say that, for example, if the value is East Village with lowercase value, after dot string dot title we have uppercase word for the first alphabet of the word. Okay, or for example here we have all the alphabets uppercase, after dot title just the first value is uppercase. So we are trying to have the consistent format in our categorical columns. And after that we can simply see, for example, the room type dot unique. We can see that how many unique room type we have. For example, private room, entire room, or apartment, or shared room. And another one is neighborhood group. For example, the neighborhood in New York City where this data set gathered. For example, Brooklyn, Manhattan, Queens, Staten Island, and Bronx. I never heard of it, and this one. And after that, for example, we can generate new feature or replace some values. For example, in neighborhood group we saw we have what values. We can simply, by calling this feature in our dataset, dot replace. For example, here we are saying that turn this column into this column. Okay, for example, if the Brooklyn starts with lowercase b, turn it to uppercase B. Or for example, if our Manhattan starts with 1T, simply change it to Manhattan with double T. which simply just replacing, and on the left side is what it's current, and on the right side is what we want to change to. Is dealing with outliers. Okay, we talked about it. In df.describe we saw how we can find outliers, and for example here you can see that we print for example with just price column dot describe. We can also just use describe for one or two or all numeric features, or for example minimum nights dot describe. Here you can see that after we generate 500 duplicate rows, our numbers increase to 49,358, and for example the minimum value for price is 0 but maximum is 10,000, and the 75% is 175. So here we can see the gap, and this is outlier. Or for minimum nights we can see that the minimum is 1 night. So for example the person try to stay in that Airbnb for 1 night, but the maximum is 1,250. So this is outlier. How it's possible to stay for 1,250 nights in even 1 year? Okay, so this is outlier, and this is the incorrect value, wrong value in our data set. Here you can see that 75% of our value stays at five nights, but after that we have this huge value. So these two are outliers. And another way we can detect outlier is to using IQR. Okay, so here for example we can find Q1 and Q3, which are quantile. Here for example we are saying that for our price feature dot quantile for 25% of the value. This one here we get it. This is the formula to get this value. And for Q3 is to use quantile and for 75% of the value, and IQR is equal to Q3 minus Q1. So we get IQR, and the lower bound is Q1 minus 1.5 cross IQR, and upper bound is equal to Q3 plus 1.5 cross IQR. Here you can see that how IQR is work. For example here you can see that this is Q1, this is the median, and this is Q3, and IQR is simply minusing Q1 from Q3. And here for lower bound and upper bound, this is lower bound, for example H equal to Q1 minus 1.5 cross IQR, and for upper bound is Q3 plus 1.5 cross IQR. Here you can see this visual, this diagram, and understand the IQR. And here we simply want to check the price outliers. We want to see that how many of our rows are outlier for price feature. We're simply saying that for price feature in our data frame, which the value are lower than lower bound, and or this one is or. If we for example use this one means and, but we are saying that or. So this means that the data frame lower than this, or the prices in data frame higher than upper bound, one of these two if happened, we want those values. We put them in price outliers, and we simply by getting the length of the price outlier, we can see that 3000 of our values are outliers. These 76 are because we run some commands here in between, and we generate some more values, but if we run all these capsules one by one, we get 3000. And here with Matplotlib we can visualize these outliers. For example, we generate two subplots in one line, and for example, for one plot we use box plot, and for another we use histogram with these values, and we print it. You can see that here. For example, for the price distribution for box plot, you can see that these circles are missing values, but most of the data exists in this section, but here are missing values. And also with diagram, you can see that these red lines, these red dashed line are upper bound and lower bound. And here you can see that after this upper bound, which is 334, all these values are that 3000 outliers. And we do the same for minimum nights. Okay, this one was for price feature, and this one is for minimum nights. We simply do the same. We get the IQR and lower bound and upper bound, and we visualize the outliers. And again, we can see that these are our outliers. And for example, here you can see that the maximum 1250 is this one, and here we can see that the lower bound and upper bound and the outliers. And for handling outliers, for example, here we can see that we just want prices for higher than 0. If we have, for example, prices lower than 0, we can drop them. Or for example, for minimum night, we can see that we want to keep the minimum nights at maximum 365. Okay, this which means that for 1 year, it depends on us. We can change these two values. For example, we can turn this to only, for example, 14 days just for 2 weeks, or keep it at 365 nights. Okay, we can handle the outliers. And the next part is to handling string manipulation. Okay, here I explain everything. For example, imagine some values in our data set for our categorical columns have some icons, or I don't know, maybe numbers, or these. For example, here you can see that we have cozy studio and this star near subway and this icon. And for example, we have these two. We simply want to drop these and just have the text cozy studio near subway. Okay, we simply with this command df name, we turn the name values, name feature values in dataset into a string first, and then replace with regex formula, which means that if we have, for example, any icon, any number in dataset, remove it with nothing. Okay, this is the first value, which we want to say that if we have these items in our this feature name, replace it with nothing. Okay, and with the second one, we are simply saying that after we drop the, for example, icons, numbers in our name, in our category feature, simply drop the space left on that data frame value. Okay, here imagine we drop these three and we have 1 2 3 4 5 spaces between studio and near. With this command we replace it, but regex /s plus, we simply cut this space into 1, and we simply get studio near this way. So we clean our dataset values. So for example, when you want to use this dataset in your machine learning models, having clear name is help your machine learning model. The next one is extracting some feature from our new feature from our existing feature. For example, in our feature name, for example, we can say that turn it to a string, and dot contains means that if it contains subway word in the name, we can put this value into df with new feature mentions subway, and then we check the df mention subway dot value count to see how many subway we have had in our data frame name feature. Here you can see that 1115 rows of the name feature have subway in that name, so we move these names into new feature. So we can see that, for example, based on this new feature, we can find the Airbnb houses near the subway. Okay, we simply gather some useful information from our dataset. And after all of these, we can validate our dataset to see that we removed or we handled missing values, or working on numeric or categorical columns, changed their data types, removed our outliers, and again we can run the same commands we first run to see that we don't have any problem. And here you can see that all value turns to 0, and with df.info you can see we changed the dataset. And this one, last review, we have a missing value because we turned the datetime into NAT. If you remember, it's better to leave the datetime to NAT to leave it as a 0. So this is exception, so we keep it this way, and that's it. And the last command is to run df.tocsv and name it, for example, Airbnb New York City 2019 clean.csv. And we simply, by running this, we save the new dataset into our machine by clicking on this file. Here you can see that Airbnb New York City, and we can simply download it, and we get the CSV file in our machine and we can use it. And here we are, this is our clean dataset. We got our dataset clean, and it's ready to use it for our future training on machine learning models, or visualizing your data, or whatever you want to do. Thank you guys, I hope you like this video. Please subscribe to my channel, leave a comment and like this video, and tell me your idea. Thank you, bye for now.